Faced with climate change and environmental pollution, humanity is at a critical inflection point. Fossil fuel energy pollutes our air and drives global climate change that affects all of us. Our oceans and waterways are contaminated with floating garbage patches, the largest of which is even bigger than Texas, that are filled with single-use items, face masks, and trash, highlighting mankind's dependence on plastic. We deeply recognize the need for sustainable alternatives that preserve our environment. It is urgent that we change our perspective on today's take, make, dispose mode of manufacturing. The team of Advancing Zero Fossil Technologies for Engineered Carbon, or AZTEC, envisions a world where greenhouse gases like methane and CO2 are converted into valuable materials for use in everyday life, like plastic and fabrics. It might seem impossible, but recent and emerging science provides the right opportunities. The AZTEC team turns global challenges into innovative technologies. AZTEC starts with renewable energy to capture greenhouse gases, then uses them to build novel, biobenign, zero-fossil materials. Why is this important?
Fossil fuels sequester carbon deep in the ground where the carbon is kept out of the carbon cycle. When we burn those fossil fuels for energy, that carbon is released as carbon dioxide into the atmosphere. Instead, we can use new technologies that recycle the carbon dioxide that's already part of the carbon cycle into energy-rich fuels such as methane.
Another AZTEC team member, Professor of Mechanical Engineering Dr. Asfa Bieni, and his team develop novel wind turbine blades to produce clean power. This renewable energy will then be used to capture greenhouse gases and convert them into simple chemicals. But how would you capture CO2 and transform it into bigger things like plastic?
There are several steps, and the first step is that we're going to design special catalysts, much like the enzymes that are in our body, but they're going to convert CO2 and electrons into useful chemicals like methane or methanol.
These chemicals are already used in industry. SDSU chemists collaborate with biologists to convert products of CO2 reduction into innovative materials using microbial fermentation. This idea is completely different from all existing CO2 conversion and storage methods.
In nature, many microbes can eat methane as their main food. Our microbes have machineries to convert chemicals into cell building blocks, proteins. And now we just have to reinforce their potential to produce proteins.
Our team develops novel fermentation approaches to enhance conversions to desired products. But the process must be improved further, and that requires collaboration between biologists, engineers, and mathematicians. The AZTEC team innovations go even further. They look for inspirations in nature to build novel biodegradable and thus environmentally friendly materials.
So we're going to use this expression system to produce a lot of really useful proteins, in particular spider silk proteins, which are Mother Nature's super material because they provide both strength and flexibility in one material. We have a lot of experience working with these proteins, and we're going to use that experience to re-engineer them for applications in the fields of biomedical sciences, defense, and industrial applications.
It takes a village to build a new manufacturing paradigm. AZTEC unites SDSU faculty with shared vision and highly complementary expertise to overturn today's failed manufacturing paradigm. By integrating their expertise and cutting-edge research, and also by training next-generation innovators, the AZTEC team aims to transform the current take, make, dispose system to an innovate, make, reinvent model. Join us.